Hey there folks, in this video we're going to review graphing exponential equations, and then we're going to learn how to graph logarithmic equations. So, to start off with, just want to review, this is page 32 in the current packet that we have. Remember, when we're graphing these, I start with my parent function here of 3x, of 3 to the x, and I'm going to find my parent points by substituting in -1, 0, and 1 in for x. So 3 to the -1 is 1/3, 3 to the 0 is 1, and 3 to the 1 is 3. Now you can check this on your graphing calculator if you like, by simply just going to 3 to the -1 and hitting enter, and so forth. Okay? And for graphing purposes, I don't care if you use the decimal, okay, because these are just approximations anyways. We really just are concerned about behaviors. And so we could also do 3 to the 0, and anything to the 0 power is 1. And then 3 to the first is going to be 1. Sorry, is going to be 3. So, with this, now I'm ready to graph my home points here. So -1, 0.3, so just somewhere in the middle is good. 0, 1, and 1, 3. So those are my non-transformed points. Now I'm going to look at my given function and I'm going to list what's happening to it. Well, it has +2, so I'm going to shift it up 2. So I'm going to take each of my points and I'm just going to go up 2. So 1, 2. This is still in the middle. 1, 2, and 1, 2. All right. So now, because this +2, I know that there's that asymptote there. That asymptote, remember, is always at the same location as our vertical shift when it comes to exponentials. So now I'm just going to sketch this as best I can, curving up. And there's a rough sketch of what the graph should look like. Now, I'm not too concerned about how steep this is. As long as it's not going straight out like this diagonally, you're okay. Okay, it should definitely be curving up though. Now, domain. It will always go left. It will continue going up and to the right. So the domain is all real numbers. The range. This graph is only above this dashed line. So that means it is greater than 2. The asymptote is always this, but with an equal sign. And that essentially covers most of what we talked about on Friday. Now, for the next one, for number 2, I'm going to list the transformations that I have going on here. I have a minus sign at the very front, so that means I'm going to have to reflect over the x-axis. It's times 3, so that's a vertical stretch of 3. And then inside, it says -4 up there with the x. So that means I'm going to move it right 4. Now, before I can do those, of course, I need the parent points. In this case, my parent function, instead of being 3 to the x, is 2 to the x. Now remember, I always use -1, 0, and 1 to get the parent points. So when I substitute that, 2 to the -1st will give me 1/2 or 0.5. Either one is sufficient. 2 to the 0 is 1, and 2 to the 1st is 2. So I'm able to plot those points now. But now, so those are my parent points. But now I'm going to reflect then stretch it by 3 vertically, and then move right 4. So I'm going to flip this over, multiply it by 3, so it's at negative 0.5, so times 3 is negative 1.5. Now, write 3. I'm sorry, write 4. 1, 2, 3, 4. There's our first point. For the second point, reflect over the x-axis. It's at negative 1. Times 3 puts it at 3. And then write 4. 1, 2, 3, and 4. And then the last point. Flip it, puts it at negative 2. Times 3 puts it at negative 6. And then write 4. 1, 2, 3, 4. Now again, this could easily be interpreted as just a diagonal line, depending on how you perceive it. But it's up to us to recognize that it is curved. There is no vertical shift here. Most of the ones we've done so far do have a vertical shift. Because there is no vertical shift, our asymptote is at y equals 0. Which just means that's the x-axis. So I'm going to try to draw this as best I can. And that is approximately how it looks. Now, for my domain, it still goes left forever, it still goes right forever. Even though it's going down very quickly, it's still going to the right. So that means it is still all real numbers. However, for the range, it is still going down, so that it's less than, and it's less than 0. So that is what we have been accustomed to doing. So that's graphing exponentials.